Dear students, welcome to Nivi's Patashala. In this video, we will be studying about finite automata. Automata means automatic, that is, a device or a machine that can perform some tasks on its own. The study of these kinds of machines and how they perform is automata theory. Finite automata is a device or a machine that performs finite set of operations. For example, a vending machine, traffic lights, car commanding you to fasten the seat belt. All these are the machine performing a predefined set of tasks or actions. Now let us study about the components of finite automata. We have input tape, control unit and output tape. Input tape is nothing but the input string where each symbol is divided into an individual cell. Then we have the control unit, which is nothing but the finite set of states. We have Q0, Q1, Q2, Q3, Q4, Q5 and Q6 to be the finite set of states, where Q0 is the start state and we can have any number of final states. Then we have the output tape, which will tell us if the input string is accepted or if the input string is rejected. If the last symbol of the input tape ends in a final state, then the string is accepted. If the last symbol in the input tape ends in a non-final state, then the string is said to be rejected. The mathematical representation of finite automata is in a 5-tuple format. We have Q, sigma, delta, Q0 and F, where Q is all the states, sigma is the input symbol which we also call as the alphabet, delta is the transitions which shows all the transitions happening in the finite automata, Q0 is the start state and F is the final state or n number of final states present in that automata. For example, here we have Q0, Q1, Q2, Q3 and Q4 to be all the states. The input we have here is 0 and 1. So these are the input symbols which we call as the alphabet. The transition here we can see that Q0 on input 0 moves to the state Q1. So Q0 on the input 0 moves to state Q1. The machine moves to state Q1. Here Q0 is the start state because here we can see there is an arrow pointing towards Q0 which says this is the start state, and here we call Q4 to be the final states. Some key points to remember are there can only be one start state, there can be one or more final states. The finite automata accepts inputs only from the alphabet. For example, this is our alphabet where we have A, B, C to be the symbols. We call A, B, C as our symbols and together they are our input alphabet. The length of a string is the total number of symbols in the string. For example, I have string to be 11010, which means I have 1, 2, 3, 4, 5 input symbols. So the length of the string is 5. Let us now see the transition diagram and the transition table. Here Q0 is a state. Here Q0 is a start state because there is a arrow pointing towards Q0. Here Q3 is a final state because we have double circle here. This is to show a transition, that is on input 0, the state moves from Q0 to Q1. This is the transition table where in the first column we will be having all the states. Here we have, in this diagram, we have Q0 and Q1. So here we have written Q0 and Q1. We have a small arrow here to represent that Q0 is the start state, and here we have a star to represent that Q1 is a final state. We will always have one start state. We can have n number of final states. The first row represents the input symbols. Here the input symbol is 0. So here we represent the input symbol 0, and then we represent the transitions happening. So Q0 on input 0 is in the state Q1. Q1 on input 0 has no transitions to go. Let us understand the transition diagram and the transition table with a better example. First, let us see the mathematical representation here. Q is all the states, where here in the diagram we have Q0, Q1, Q2, Q3 and Q4 to be all our states. The input symbol, that is the alphabet, is 0 and 1. Q0 is our start state and F is our final state, which is Q4. In the transition table, in the first column, we will be having all the states Q0, Q1, Q2, Q3 and Q4, where Q0 is represented as the start state with a small arrow and Q4 is represented as the final state with a star or the asterisk symbol. So, in the first row, we have 0 and 1. That is, we will be having all our input symbols here. So, in this diagram, all the input symbols are nothing but 0 and 1. So, here we have 0 and 1. Now, let us see the first transition, that is Q0 on input 0. That is Q0 on input 0. The state moves from Q0 to Q1. So here we have written Q0 on input 0 moves to Q1. Then we have Q0 on input 1 moves to state Q3. So Q0 on input 1 moves to state Q3. Now let us see for Q1 on input 1 moves to Q2. So Q1 on input 1 moves to Q2. Q1 on input 0 has no transition. So now let us see from Q2. Q2 on input 0 moves to Q4. Q2 on input 0 moves to Q4. Q2 on input 1 has no transitions. Then we have Q3. Q3 on input 0 moves to Q4. And Q3 on input 1 has no transitions. Then we have Q4. Q4 has no transitions either for 0 or for 1. The types of finite automata are deterministic finite automata, non-deterministic finite automata, and epsilon non-deterministic finite automata, which we will be studying in detail in our upcoming videos. Thank you for watching. Don't forget to like, share and subscribe.